Hello friends, and I welcome you all in today's class. This is a class on MCQs and previous year questions. Today I've got some more MCQs for you and with a previous year question as well. In the previous class, I gave a homework to you guys and I did get some comments as well, some answers as well. So let us solve that question first and see what the answer of that question will be. This was the question. Statement first, humidity refers to the amount of water vapor present in the air. This is the first statement. Second statement is relative humidity is the ratio of the actual water vapor present in the air to the maximum amount of that can be withheld by air. That's number 2. And number 3 is relative humidity is highest when the air temperature is lowest. These are some of the statements that are given and we have to answer these. Starting with the very first. What is humidity? Humidity is actually the amount of water vapor present in the air. That is true. This is a factual knowledge that humidity is the amount of water vapor that is present in the air. Now, what is the relative humidity and how is relative humidity decided by the temperature? Let's try to learn that with an example. Starting with the very basic example, suppose you have a bucket which is 10 liters. This is the capacity of the bucket, 10 liters. Okay, that is the total capacity. It is empty right now. It is holding nothing, but the capacity of the bucket is 10 liters. Now, you pour water in this, say 5 liters up until here. You have put the water in this, that is 5 liters. So the content in this is 5 liter. So these are two different things. What is the actual capacity of the bucket and how much water is present in the bucket? This is how the things of relative humidity, absolute humidity and other things will work. Now we'll take the same example in respect to air. With respect to air, when we talk of the capacity of the air, what is the total capacity? Irrespective of how much of the water is present, the vapor present in the air, what is the actual capacity of the air? We have an air parcel. See, now you got the bucket example. Now look at this. This is, just a second. This is the parcel of air that we have here. Okay, this is the parcel of air. And its capacity is again the same. It will have some capacity. Let's not measure it in liters because humidity is not measured like this. So this will have some capacity. Although it can have huge capacity, but it's not necessary that entire air will be saturated. Say now if this is the capacity of air and it is holding this much of vapor, only this much. Okay, just in the case of this bucket, this was a total capacity of the bucket and it was holding 5 liters. Likewise, you can see here, you can see that the capacity of the air parcel is larger as compared to the amount of vapor it is holding. How is it related to humidity? Now we have a concept. The total capacity is that is the total capacity that the bucket have is the total capacity. See, this is the total, just a second. This is the total capacity. Okay, total capacity. And it is holding this much of vapor, so we will term it as absolute humidity. So absolute humidity is the amount, actual amount of vapor that is present in air. This much, 5 liters that is present is the absolute value. Likewise, this much that is present is the absolute value of how much vapor is present. So this is the thing that is here in blue is the absolute humidity. Okay, this is absolute humidity. And what is the total capacity called as? Humidity capacity. Total capacity is also known as humidity capacity. Clear? So we have two concepts here. First one is the absolute humidity and second one is the humidity capacity. So if you are asked what is the humidity capacity is the total capacity that is there. This bucket, it is 10 liters. That is the humidity capacity. 10 liters is the humidity capacity. But it is only holding 5 liters of water. That is the absolute humidity. What is the absolute amount that is present? So how will it decide what the relative humidity will be? So relative humidity is equal to absolute humidity divided by humidity capacity into 100. This is relative humidity. So amount of vapor that is present in the air divided by the total capacity of that parcel of air into 100. That will be your relative humidity. Now you can use this example where you are 5 liters and 10 liters. If you use this example, you will be dividing 5, that is the absolute humidity, divided by 10, that is the total humidity. Okay, humidity capacity into 100. So it will be 50%. Your answer will be 50%. 50% is the answer. That is relative humidity is 50%. You might have seen it in the weather forecasting and all. The relative humidity is this much percent and that much percent. This is how the relative humidity is calculated. That is the absolute humidity divided by the humidity capacity or the total humidity that can be there in the parcel of air. Now, let us go back to our question. First statement is already done. This is correct. Then the second statement. Relative humidity is the ratio of actual vapor present. That is the absolute humidity. Actual vapor is the absolute humidity that I just mentioned in the air to the maximum amount that the air can hold at a given temperature. It is the same that I just mentioned. It is the absolute humidity, that is the total present vapor present in the air divided by the total capacity it can withhold at a temperature. That means this statement is also correct. So our second statement is also correct. Coming to third, relative humidity is highest when the air temperature is lowest. This is related to temperature. If we go back to our example here, this parcel of air that I have drawn here, see, this parcel of air will be able to hold more vapor at higher temperature as compared to lower temperature. That means when the temperature is more, relative humidity will be less. See, because here when the temperature will be more, if the temperature is more, I am telling you the absolute humidity is, let us keep absolute humidity on hold for a minute. When the when the temperature will be higher, the humidity capacity will be higher as well. So the example of 5 liter and the 10 liter bucket, let's take that as an example. When we solved it earlier, we got answer 50%. Okay. Now I am telling you that when the temperature will be more, the capacity will increase. That is, this 10 is going to increase to 15. It will go to 15. The capacity will increase and the absolute humidity will be the same because it's not increasing. We're just focusing on the capacity. With temperature, the capacity will increase. Or in other sense, if this is the humidity capacity at certain temperature, if the temperature is increasing, this box will also increase. The capacity will increase. So this has gone to 15. Now, if we're talking of a higher temperature, how will you solve this? You got 50% answer at a certain temperature. But now when you increased the temperature, it will become 5 by 15. That is 1 by 3 into 100. That's around 33%. So as the temperature will increase, relative humidity is falling. There is an inverse relation with the temperature. I hope this is clear to you how relative humidity changes with temperature. Here you can see when the temperature increased, earlier the relative humidity was 50. But as soon as the temperature increased, relative humidity went to 33%. That means it fell. That means there is an inverse relationship between these two. So relative humidity is highest when the air temperature is lowest. Exactly, that's what I mentioned, that there is an inverse relationship between absolute humidity, relative humidity, and temperature. These things you need to know. Though what should be the answer here? All of the statements are correct. So answer D, 1, 2, and 3. There was an answer as well in the comments. Kudos, you got the right answer. So let's go to next question. Question number 2. Consider the following statements. Consider the following statements about El Nino. El Nino is characterized by unusually warm ocean currents in the central and eastern Pacific. So I'll explain, before we read the statements, I'll just explain you what El Nino is and what normal conditions. This is the southern Pacific or the central part in which we'll understand what happens during the normal conditions. During the normal conditions, this is the South American continent and this is Australia. You will know that there is a wind easterly that is blowing around the equator. These winds that I'm drawing, these are the winds that are present there, and on equator there is a current in the water, that is equatorial current. This current, this drives the warm water from this place towards Australia. Here, all of the warm water gets driven to this place, that is Australia, and the warm water will accumulate here. Is it clear? The warm water accumulates here. It will rise eventually because the warm water will make the surrounding air as well warm. When the air will rise, there will be rainfall around this region. This is the normal condition. Just one thing at a time. This is a normal condition, that during the normal conditions, the winds will drive the warm water away towards the Australian coast. East Australian here, near this region. This is the normal condition. During El Nino, what happens is that the trade winds become weak, that were driving the water towards Australia. They become weak, and because they become weak, the counter-equatorial current becomes strong. That is, the equatorial current is not that strong as well. Because of that, you can see the accumulation of warm water near Australia is less. Okay, so that means you will start, the warm water accumulation will start around this region, that is Central Pacific region, and near the Eastern Pacific, that is South America. This region, that's Australian region, you will not have that much of warm water as is present in the normal conditions. Talking of this thing, if you look at the first statement, El Nino is characterized by unusually warm ocean temperature in the central and eastern Pacific. Right. First statement is correct. El Nino usually occurs every 2 to 7 years. Yes, this is a factual knowledge, you should have it. It is not necessary that it will occur, but usually it will occur every 2 to 7 years. This is correct. El Nino typically leads to increased rainfall in Indian subcontinent. For this, you will have to understand, this is the map of the world, and this is the Pacific, and here is India. Normally around this region, you will see the warm water will accumulate here during the normal conditions. But as I told you, when the warm water accumulates here, it rises up. See, look at this diagram that I'm drawing. This is Australia, from where the warm water was accumulating around this. After the accumulation, the warm water will start to warm air will start to rise. After it rises, it will diverge and a branch will go like this, and eventually it will come down. When it will cool, it will come down as well. Okay, this is the cross section that I'm showing you. This is the top view. When the warm air will start to rise from here, it will diverge and eventually it will come down near this region. It will come down near this region. This is near Madagascar, Mascarenes to be precise. When it will come down near this region, this is the normal condition that I'm talking about. Here you will see when the warm air will come down, there will be the cold air will be accumulating at this region. The pressure will increase. Why? Because there will be too much of air. The pressure increase, as you know, this is India and this is the Tropic of Cancer. Here you have summertime. The land is already heated, the pressure will be low. So the warm air will start, the air will start to move. The winds will start to move towards India or the subcontinent, entire subcontinent. When the winds will come towards India, because they're traveling along the Indian Ocean, they will bring along with them rain as well. This is during the normal conditions. Now, what will happen during El Nino conditions? This thing will not take place at all. That is, warm air will not. First of all, the warm water will not accumulate. When the warm water will not accumulate, the warm air will not be present as well. When the warm air will not rise at this place, this process at this place will not take place at all. This thing will not happen at all. That means the rainfall will be poor. because of this region. So that means the third statement that we mentioned here, El Nino typically leads to increased rainfall, is wrong. Why? Because it will usually lead to drought-like conditions. So the third statement is wrong. That means you can eliminate the third. Only 1 and 2 is correct, and that is what I was telling you, how the warm water will accumulate near Eastern and the Central Pacific. I hope you understood. This is a very good concept that we will learn when we discuss the climatology in detail. I hope this is what you have learned up until now. This is question number 3. This is the easiest question of them all. You can learn it in a second. That is about the composition of atmosphere. Nitrogen is the most abundant gas in the atmosphere. Correct. CO2 is the third most abundant gas in the atmosphere, and then carbon dioxide makes up 21% of the Earth's atmosphere. This is a very important thing. See, most of the students might get confused here because most of us know that only 3 gases, as we have talked about: nitrogen, oxygen, and carbon dioxide. So we'll say, okay, nitrogen is highest, then there will be oxygen, and finally there will be carbon dioxide. But this is not the case. This is where you can make a mistake. See, when we talk of the concentration of gases, you will see nitrogen is about 79%, oxygen is about 21%, and then carbon dioxide is not the third most abundant gas in the atmosphere, but it is argon, that is about 0.9%, and we have carbon dioxide of about 0.04%. That means carbon dioxide is the 4th most abundant gas. Most of the students might get confused with argon because argon is normally not that we learn about too much. We only know about carbon dioxide and all because of global warming. So carbon dioxide is not the 3rd most abundant gas in the atmosphere. Then carbon dioxide makes up 21%. Of course not. That is oxygen. So only one statement is correct. First one. Clear? This was the easiest question of them all. So let us go to next question. Consider the following statements. This is regarding the temperature inversion. Temperature inversion. First of all, what is temperature inversion? If you know about the normal conditions, if you look at this image, sorry, I think the image is missing here. See, if you look at if this is the atmosphere, okay, normally what will happen in the troposphere is that as you go, the higher you go, the cooler it is. With every 1 kilometer, there is a 6.5 degree fall in temperature. That's on average. This is the normal lapse rate. This is known as normal lapse rate. With every, as you go higher, it will be cooler. With every 1 kilometer, you will find 6.5 degrees drop in temperature. But when we talk of temperature inversion, what will happen is that as you will go higher, the temperature will increase. This is something is going in the opposite direction. That means there is inversion. Normal condition is not being followed in case of temperature inversion. As you know, when you're going higher, it's cooler. But in case of inversion, you will see it is more hot, or more temperature is more as you go higher as compared to near the lower levels. So if you look at the statement, temperature inversion can be caused by the cooling of the Earth's surface at night. This is the first statement. So is there a possibility that this can happen? Yes, of course. Why? Because when you look at the surface of the Earth, this is the surface of the Earth. This is the surface of the Earth. Okay. Now what is going to happen is that at night, during winter times, usually what happens is that because of the cool and the long nights, you have the property of the land is that it heats up quickly as well as cools quickly. So during day, the land will heat up. The temperature here, the air will also be a bit warm. But as soon as the night will start and the temperatures will start to fall, the land will cool quickly as well, which will result in drop in the temperature. When the land will cool, the warm air, when it will start to rise, and this cool air near this surface will, near this surface we will have the air that will also cool down because it will be in contact with the ground. Because of that, the cool air, it will cool, and the air above it will not be that much cooler. So this air, if the air in contact with the ground will be cooler as compared to the air that is not. See, this is the air that is in contact with the ground. This will be more cooler as compared to the air that is not in contact, that is higher. Why? Because the ground is cooled up more quickly, the land will cool up more quickly. That is why you will find a warmer layer of air above the cold layer. Exactly what I was telling you. What is temperature inversion? As you go higher, you will find higher temperature. That is not usually in case of normal situations. So here you can see this is the cooler layer that is lying under the warmer layer. That is the inversion of temperature. So yes, the first statement is correct. That is the temperature inversion can be caused by cooling of the earth's surface at night. The second statement, temperature inversion can occur when the warm air moves over the cooler air. Yes, that is again same. Why is it? Because when the warm air will move over the cooler surface, the area that I just mentioned here is that the warm air, when it will be in contact with the cooler ground, the temperature of the lower layers will fall, and the upper layer will be warmer as compared to the lower layer. That means this statement is also correct, because you can see the temperature inversion. You are going higher, the temperature is also increasing with height. However, that should not be the case in normal conditions, where higher you go, the cooler it is. So the lower layer will be cooler. The layer that is in contact with the ground will be cooler as compared to the layer of the air that is above this layer. So this statement is also correct. Then we have the third statement, temperature inversions are rare in mountainous regions. First two statements are correct. Now talking about the third statement, it is rare in the mountainous regions. That is, in case of mountainous areas, it will not be possible. What do you think? Is it possible or not? This is a mountain and this is a valley in between, and there is another mountain. So the statement is that in these regions the temperature inversion is not possible. If you know, as I already mentioned, with the rise in the temperature, with the height, the temperature will usually fall. But what happens in these cases is, during day, as the land will heat up quickly, this area will heat, because this is at the height, it will receive solar insolation and it will heat up. This area will heat slowly as compared to this area. First of all, when the sun will start to shine on these peaks, they will start to heat up. But what will happen during the night is that once the sun sets, because this is at the height, the surrounding air will start to cool. This air will start to cool. What will happen is that the cool air here present at this place, because this is the colder air, it is heavier. As you know, the colder air is heavier. It will start to move and the warm air from these places will start to rise. See, the yellow arrow that I'm showing you is the cooler air that is coming from this place. See, the yellow air will start, this will start to come down. That is the colder air, because it is a denser air. It will start to come down the slope, because there is a slope. It will come down the slope, and the warm air in this region, that is this region, will start to go up. The warm air will go up and the colder air will come down. That is again the temperature inversion, as I have already mentioned. This area will be taken over by the cold air, and we will have a layer of a warm air above it. This area will be cold air, and then we will have a layer of a warm air above it here. That means colder air is below and the warmer air is above. That means in case of mountainous areas, there is a possibility of temperature inversion. That means the third statement is again wrong. Only two statements are correct. That is regarding the temperature inversion. I hope you understood all these. Now coming to the last question, and it is also a PYQ. It is asked by UPSC as well. This is an assertion and reason question, but it's very easy. Areas near the equator receive rainfall throughout the year. First statement, and the reason is that high temperatures and high humidity causes convection rains in the most afternoons. Is it right or wrong? What do you think? See, this is the Earth, this is the globe, this is an Earth. What happens on the equator is that there is more insolation, more solar insolation as compared to the poles. As you can see, this is sun, and it's more focused on this region, that is the equatorial region. On this, you will have more solar radiation, more heat. Because of that, more heat, the evaporation will also be more. When the evaporation will also be more, the rainfall will also be more as compared to these regions. So you will see on equator, you will more often than not see it is very humid. There is too much of rain near this regions because of the high solar insolation, more evaporation, and that leads to more rain. So that is the first statement. Areas near the equator receive rainfall throughout the year. Yes, because of the solar insolation. This is the first statement, that they receive rain throughout the year. Talking of the second statement, high temperatures and high humidity causes convectional rain in the afternoon. Convectional rains, what is the convectional rains? First of all, you should know what the convectional rains is. When the sun heats the place, then the air will start to ascend, the air will start to rise. When the air will rise, it will form cumulonimbus clouds. That is a convectional rain. There are other types of rain, that is the cyclonic rainfall and the orographic rainfall. That we will learn in climatology. Right now, this is the convectional rain. When the water is heated, the ground is heated, the air will rise. When it rises up, that is a convection, it leads to convectional rain. But is it mostly during the afternoons? What do you think? We know that high temperature and high humidity will cause rainfall, but will it be mostly during the afternoons? Yes, again correct. Why? Because when the sun will come out, it will take some time for the ground to heat, the water to heat, and then it will evaporate. And by the afternoon, all the convection will take place, and afternoon it will be rain. And in the afternoon, there is a very good chance that it will be rain as compared to early mornings, because the sun will not be that much quickly heating up the ground and the water, that the sun will come out and the water will evaporate. No, that's not the case. It will take some time. The ground will heat up, the water will heat up, then it will rise, there will be evaporation, then there will be rain, and this process takes time and it will be up to the afternoons. Most of the times it is up to afternoons. So now tell me the assertion and the reason. As you know, what's the assertion and the reason? First statement is the assertion, and is the reason correctly explaining the assertion? High areas near the equator receive more rainfall. Assertion is correct, and the reason is also correct. But is the reason correctly explaining the assertion? Yes. Why? Because near the equator there is rainfall throughout the year, and it is because of the high temperature and humidity we understand that there is the rise of the these convection that leads to rainfall. Because of this very reason, the assertion is explained by the reason. That means both A and R are correct, and the reason is correctly explaining the assertion. I hope you understood the 5 questions. I've got a homework for you as well. This is the homework for you. This is regarding the temperature inversion. Please tell me in the comments what will be the answer of this question as well. I hope you understood everything, and if you're preparing for UPSC, then we have got a great offer for you. On Unacademy, you will get all the benefits at just rupees 24,999, where you will get top faculties that will teach you in all the languages, that's English, Hindi, and bilingual as well. And if you want further discount, use my code and you can get some more discount as well. That is A, T, and F. That is all from my side. I hope you liked the class. If you did like the class, then subscribe to our channel. See you next time with some more MCQs. Goodbye.